Okay, so in this video what we're going to look at is how to find the yield to maturity on a bond. So let's take a look at our problem. So here's the question. What is the annual yield to maturity of a 20-year bond which makes semi-annual interest payments, has a par value of $1,000, has an annual coupon rate of 4.5%, and has a current price of $768.52? So first, let's kind of evaluate what we have here. Notice that the bond has a current price of $768.52 and a par value of $1,000. So that means that this bond is currently selling at a discount. So if the bond is selling at a discount, that implies that the market rate actually needs to be above the annual coupon rate. So we should get a market rate or an annual yield to maturity that is above this 4.5% if we've actually done this properly. So the first thing to do now is to figure out what we have in terms of data. So let's go ahead and write down the inputs that we've been using for a lot of these examples. So NI, PV, FV, payment, and then type. Alright, so in this particular scenario, as always, notice that NI and payment have to connect to the same period of time. So, notice that this bond makes semi-annual interest payments. So if it's making semi-annual interest payments, then N needs to be the number of semi-annual periods. So if it is a 20-year bond that is making semi-annual interest payments, the number of periods, since there are 2 periods per year and there are 20 years, will be 20 years times 2 periods per year for a total of 40 periods. Now the interest rate is actually what we're trying to find in this case because we were asked to find the annual yield to maturity. So we're actually trying to find the interest rate. We don't know what that is at the moment. And the present value would be what the current price is. So we'll put that in as a negative $768.52. And I'm going to come back to why that's negative here in a moment. Future value is the cash flow that happens at the end. And the cash flow that happens at the end of this bond's life is the $1,000 par value. So we'll put in the $1,000 here. Okay. So we have the $1,000 future value there. The payment is for the coupon payments that are happening each year, or pardon me, each period. And in this case, we know that we have an annual coupon rate of 4.5%. So in decimal form, that would be 0.045. And well, it's 4.5% of 1,000, so times 1,000. So 4.5% of 1,000 would give me the coupon payment per year, but it makes payments semi-annually. So I will take that annual amount and divide that by 2. So in this case, I recommend that you pause the video for a moment and work that out and see what you get for the semi-annual coupon payment. Alright, so if you took a moment to work that out, what you should have gotten for the semi-annual coupon payment was $22.50. So that is our semi-annual coupon payment. And as we are dealing with a bond, most bonds make payments at the end of each period, and we aren't provided with any information to the contrary. So we are going to assume that this type is end, so the payments are happening at the end of each period. So let's talk about this present value, future value, and payment part. So if you buy the bond, then you would actually have to spend money today to buy it, and that's why this would be negative. And then if you bought that bond, you would get $1,000 at the end. That's why this is positive, because you would receive it. And you would be getting $22.50 every 6 months, which is why this is positive, because so you would receive it. So because you're receiving this, it's positive. Because you're receiving this, it's positive. And because if you bought the bond, you'd have to actually pay to buy it, then this is negative. So that's why the present value is negative, the future value is positive, and the payment is positive. So at this point, what you do is you move your cursor in the time value money solver up to the interest rate line, and then you'll hit alpha and enter, so you will solve to find the interest rate. And at this point, I recommend that you pause the video to do that and to see what you get. Okay, so if you did that, what you would have gotten for the interest rate is 3.3 007, and I held on to a couple extra decimal places here. So 3.3007, as our rate. Does that mean we're done? The answer is no, we're not done yet. Let's talk about why. Recall that N, I, and payment have to connect to the same period of time, which in this case is semi-annual because we're dealing with semi-annual payments. So this is the number of semi-annual periods, which is 40. This is the payment per semi-annual period, which is $22.50, which means that this is the interest rate per semi-annual period. And note that we're asked for the annual yield to maturity. So assuming we're asking for the nominal annual yield to maturity, we're going to take this rate here, which is per semi-annual period, and multiply it by 2. So 3.3007% times 2, and I recommend you pause the video to work that out. And if you pause the video to work that out, and rounding it off a little bit here at the end, that should give us 6.60%, and that is our annual yield to maturity. And note that if this is our annual yield to maturity, or our annual market rate, which applies to this bond, notice that that is above the coupon rate, which implies the bond should be selling at a discount, which we already determined based on the information in the problem. So the nominal annual yield to maturity for this bond is 6.60%. Now you can also find this in Excel. So the way to find this in Excel is equals rate, and then open parentheses, and the first thing it asks for is the number of periods. So we can do 20 years times 2 periods per year, so 20 times 2. And then it asks for the payment, which we've already found here of $22.50. Then it asks for the present value, which we will put in as a negative $768.52. Then it has an optional value for future value, which we will need to use because we do have a future value, and that's 1,000. And then it actually has options where you can tell it whether it is an ordinary annuity or an annuity due with these payments. But if you leave that argument off, it will assume that it is an ordinary annuity, which it is, so that's fine. We can leave that off. And if you want to help it out, you can actually provide an optional argument that gives it a guess at what the rate might be, but you can leave that off too. So that's all that we need. So I recommend that you try this in Excel, pause the video, and then see what you get, and let's see how we did. Okay, so if you try that in Excel, what you should have gotten was 3.3007%, which is the same number that we got up here. Now notice that this particular number is of course semi-annual because this was a semi-annual number of periods, and this was a payment per semi-annual period. So this is the rate per semi-annual period. So to get the final answer, we would need to take 3.3007% times 2 in order to produce our overall number, which is 6.60%. So that would be our nominal annual yield to maturity on this particular bond. And of course, remember when you did this in Excel, this payment was positive because it was a cash inflow. This future value is positive because it would be cash inflow. But this present value that you put into this formula was negative because that would be what you would have to pay to buy the bond. So you have to watch your signs when using that formula in Excel. But as it turns out, you're doing the same thing that you're doing here in the time value money solver. So that's not too bad. Now it's worth noting at this point that this is our nominal annual yield to maturity on this particular bond. And significantly, in a lot of cases, when you look up bonds and various resources online and so forth, what's actually quoted is not the price of the bond, but actually the yield to maturity. And the reason for that is when people are buying bonds, they're typically financial institutions that are doing this, and they're buying huge blocks of bonds. And really in that case, when you're dealing with that sort of scale, what's largely significant is what yield to maturity you're getting, because if I specify the yield to maturity and I know what the future value of the bond is, I know what the payments happen to be, and I know how many periods, well in that case I've specified what the price is anyway. So I don't need to report both, and most of the times they'll report the rate of return because that's giving you an idea of what rate of return you're getting on your investment. Now sometimes for bonds what you will also see is a yield to call. To calculate a yield to call instead of a yield to maturity, you would follow fundamentally the same process here. However, N would be a little bit different because N, instead of being the number of periods until maturity, would be the number of periods until the issuer of the bond calls it early. And the future value, instead of possibly being par value, it might be a number that's slightly different because it might be a different value that the company has to pay if they buy the bond back early. So you'd have to change the number of periods and you'd have to change possibly the future value. But otherwise, you could still solve for the I, and in that case, that would give you the rate per period, which you could then turn into an annual rate, or nominal annual rate, and that would be your nominal annual yield to call if you use the number of periods until it was called and the price that was paid when it was called. And that is how you find the yield to maturity on a bond, and with the appropriate adjustments just discussed, that would be how you could find the yield to call on a bond as well. I recommend that you try some examples and see how you do.